Good morning to 100% here. This is N. Kavin, Assistant Professor, Department of Mechanical Engineering, Koganadu College of Engineering and Technology. Today I am going to present a topic on metal casting processes. Metal casting process is one of the manufacturing process by converting the metals into the molten state and poured into the sand mold with the help of casting to take a required shape of the metal. Sand casting. Casting is the one of the process used for making the components of complicated shapes in large quantity. It is the process of producing a metal parts by pouring molten metal into the mold cavity of the required shape and allowing the metal to solidify. Sand molds. Mold is the cavity of required shape made in the molding sand or in other materials. Pattern. It is the model of the required casting made in wood, metal and plastics. These are the types of patterns used for casting the metal to solidify and taken out for the required shapes. First one is solid patterns. Solid patterns are in cuboid, pyramid shapes. So we can pour the molten metal in the solid casting pattern. Then it can be used for solidify and it can be used for the required shapes. Split patterns. Split patterns have the two dies, upper die and lower die, which both dies are connected with the double pin. So it can be easily used for the casting of the materials of the required shapes. Next, loose piece pattern. Loose piece pattern, it consists of one solid piece on the bottom side and one loose piece on the upper side. The gap between the solid piece and the loose piece will be filled with the molten metal and can be used for solidify. So the molten metal can be changed as the required shapes. Match plate pattern. Match plate pattern consists of the four patterns of different shapes and sizes. They are connected with the pathway of the pattern match plate. So the molten metal is pulled into the pathway of the molten match plate. So the required shape can be easily identified. Sweep pattern. Sweep pattern consists of one metallic stick surrounded by the two mold cavity plates. So the we sweep the mold cavity and pour the metal into the molten state. The mold cavity is filled with the molten metal and it can be easily used. Skeleton pattern, segmental pattern and shell patterns are used for making the required shape of the hollow shaped sizes of the casting material can be used. Example, pipes like that can be easily solidified and can be easily used for the patterns. What are the pattern materials used? First one, wood. Teak wood, white pine, rosewoods are highly used as the pattern materials. The metal spray coating up to 0.25 mm thickness and coating materials like zinc and aluminum to avoid the moisture absorption and good surface finish. Advantages are it is less weight, cheap, easily available, easy for work, easy to cut, easy to fabricate, easily repairable, easily smoothed by varnishes and paints. Limitation, it absorbs water from the sand and changes its shapes. It has no uniform structure. It has high wear tear by sand, hence it can be used for mass production. It cannot be used in machine molding processes. Metal, mostly used when larger number of castings. Cast iron, brass, aluminum are highly used metal patterns. Advantages, long life, accurate in size, smooth surfaces, mass production is possible. It does not absorb moisture and deform in size. It can be used for rough handling. Disadvantages, it is costlier and heavier than wood. It cannot be easily repaired. Ferrous patterns can be restored. Plasters, Plasters of Paris or gypsum cement is used. It can be easily made into difficult shapes and easily worked. Plastics. Plastics patterns is a cast from a wooden pattern called master pattern. Lightweight but strong and not affected by moisture. More resistance to wear. Polyacrylates, polyethylene, polyvinyl chlorides are used. Wax. It is used in investment castings. Pattern allowances. First one, shrinkage allowance. Metal shrinks or solidification and contracts on cooling to room temperature. Machining or finish allowance. A pattern is made larger than the required castings for finishing purposes. Example, for shrinkage allowance, cast iron is 10.4 mm per minute, but cast iron is 2.5 mm only for machining allowances. Draft or taper allowance. By draft is meant that taper provided by the pattern maker on vertical surfaces of the pattern so that it can be removed from the sand without tearing away the sides of the sand mold and without excessive wrapping by the molder. Wrapping or shack allowance. Before the withdrawal from the sand mold, the pattern is wrapped all around the vertical faces to enlarge the mold cavity slightly, which facilitates removal since it enlarges the final casting made, it is desirable that the original pattern dimension should be reduced to account for this increase. Distortion or camber allowances. Sometimes castings get distorted during solidification due to their typical shapes. For example, if the casting has the form of letter U, V, T, or L, etc. Types of molding sand: green sand, rice sand, phasing sand, loam sand, baking sand, and potting sand. Green sand. Moist state is known as a green sand, 5 to 8% of water, 16 to 30% of clay. Dry sand. Prepared in dry stage, used for large casting. Mold does not cause defects which cause due to moisture. Phasing sand. Used directly, cover the surface of the pattern and comes contact with the molten metal. It contains silica, clay, talc, graphite. Loam sand. It consists of fine silica sand, fine refractories, clay, graphite, fiber, and water. It is used for bell, roller, pulley, etc. Backing sand. It is used for backup of phasing the sand and fill the whole volume of the mold box. Parting sand. It is used when a casting is made up of two halves with a cope and a drag. It is sprinkled over the pattern to avoid the stacking of the green sand. Properties: porosity, plasticity, adhesiveness, strength or cohesiveness, refractiveness, collapsibility. Porosity: it is a measure of molding sand by which the sand allows the steam and the gases to pass through it. Otherwise, casting defects such as blowholes will occur. It depends on the quality and the quantity of clay moisture, degree of compactness. Plasticity: it should flows around over the pattern and uniformly fills the flash. Adhesiveness: it sticks or adheres to molding boxes. It does not fall out when the flash is lifted or turned over. Strength or cohesiveness: it should have sufficient strength so that the mold does not collapse during lifting and shifting, turning, pouring of the molten metal. Refractiveness: it should have high resistance, high temperature of the molten metal depends upon the purity of the sand size. Collapsibility: it should collapse easily after casting solidifies. Okay, that's all about the basic details of the sand castings. Thank you for watching.